Hey there, this is video 518, and we are looking at the area under the curve. So we're kind of going from a histogram to frequency polygon. Now we're gonna take it one step further and talk about the area or the percent underneath the curve. All right, so you may recognize this from a previous video. It happens to be a fairly lovely graph, which talks about employees at a cereal factory, and this is frequency, and this is the year's number of worked. And you can see you've got a pretty good curve. Pretty good curve. Now, kind of did that wrong. If I was drawing a frequency polygon, it would go middle, middle, middle. Not that far off. Middle, middle, oh, middle, middle. Right, it's not perfect, but it's not bad. Right? It's not exactly a smooth curve, but it's close. Right? I'm not going to go down the other side, but you get the idea. Now, what would happen if you took this data and instead of doing years worked, what if you split it into 6 months periods? So I worked half a year, year, year and a half, 2 years, 2.5. What would happen to the number of bars you'd have? Well, of course you'd have more. What if you divided it out into the number of months? You'd have a whole lot of bars now, wouldn't you? Right? Because for every year, there'd be 12 bars. And oof, that'd be a graph. And I do not want to draw that. But what I need you to know and realize, more bars. And, okay, for those of you that are thinking a lot, you'd also be trying to tell me that there's probably going to be less numbers in each of them. Fair enough. But I'm really just worried that there'd be more bars. And what would happen to our polygon? Well, if you're connecting more dots and the dots are closer together, what would happen to the frequency? It would become smoother. I don't know if you just heard my co-host Jelly Bean. She doth protest too much. So she's hanging out in her crate and not really pleased about that right now. It's okay, she'll be fine. All right, so dun, 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 look at this cool curve. You need to memorize it. Yes, you just memorize it with all the numbers on there. Now, honestly, you don't need to worry about this part right now. In fact, you really don't have to worry about that part at all. But it's this top part that is the most important. You know what? I'm just going to leave that right there because that stuff on the bottom scares me right now. All right, the curve below shows a frequency polygon. Kind of, and I'm just going to call it a frequency polygon with so many intervals that it made this beautiful smooth curve for us. And instead of having frequencies, like the number of people at the cereal factory, look at it up here, it's been converted into percents. So then instead of, I don't know, this one, oh, you can't see when I'm doing that, being 200 people, you would have to figure out what the total of everybody was, and then you put 200 divided by that, and you just convert it over to a percent. But the nice part about this, oops, I said I was leaving that paper there, my bad. All right, is these numbers don't change. So for something that is considered to have a normal distribution, let's see what we need to know. This part here, what's that, what's that, what's that? That is mu. That's the mean. And specifically, it's the mean of an entire population. And sigma is a standard deviation. Now, I guess I can let you see this stuff down here. It just looks scary. Look, look, look. But there's my mu, right? And this is mu plus sigma. So from here to here is one standard deviation. And then from here to here is one standard deviation. So that's why this says mu plus 2. So we added one standard deviation there, and then we added another standard deviation to get to there. And then guess what? We need one standard deviation. I should be using a sigma thing, but then I'm going to have that to get over to there. I should put plus, 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 guess what we do to go that way? And that's what do, yes. Everything's backwards. All right, if we're going this direction, we're gonna go minus 1 standard deviation, minus 1 standard deviation, minus 1 standard deviation, minus 1 standard, oops, don't need that one, oops, leftovers. Don't worry about that last little tail. That includes everything that's left over. So we don't have to go more than 3 standard deviations in each direction. Which reminds me, I'm going to show you something cool. And I want you to draw this on yours because I don't think I have this picture anywhere else. So from here to there, 34 plus 34, that'd be 68%. So 68% of your population is within 1 standard deviation of the mean. I have a feeling. Aha, I wrote it down there. Okay, so 68 goes here. Now, we want to go 2 standard deviations. This is going to be such a messy page when we're done. All right, so I need to add 13.5, that's this box, plus a 34, plus another 34, plus a 13.5. And that gives us 95% of the population. That goes here. So this is where it gets cool. If you know the mean and the standard deviation, then 95% of the data lies within 2 standard deviations of the mean, up and down. And if you add on to get 3 standard deviations of the mean, I'm going to go way up there. Well, I already know that if this much was 95, so now I'm going to add plus 2.35, plus 2.35, and I should get 99.7% of the population. So almost all of your data is always within 3 standard deviations of the mean. So that should be 99.7. So that gives us a lot of really strong predictability, ability to predict. Yes, and we're going to do a bunch of questions like that. So I'm sorry I messed up the picture. This is important stuff to remember. So these numbers, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15%, never change. The 68, 95, and 99.7, never change. The only thing that's going to change is the numbers that we write along the bottom. And we're not going to be writing that stuff because that's pretty messy. All right, that's the end of that video.